Hello, today we will discuss semiconductor physics, and especially we will discuss the energy level of an atom and energy band gap in solids. For conductivity of a material, conductivity is the ability of a material to conduct electric current or flow of electrons in the medium in the solids. Our conductivity is high in metals like copper, and conductivity is low in insulators and also insulators such as rubber. And semiconductor is the conductivity is in between high and low, and there are many kind of semiconductors like germanium, silicon, etc. We will discuss the Bohr atom and Bohr model. It is similar to the solar system. Electron at the outer uh, region, and the nucleus is in the center of the atom. There are different elements. This is hydrogen, so one proton and one electron and no neutron. And other isotopes have one extra neutron or two extra neutron, deuterium and tritium. Similarly, helium, He4, 2 proton, 2 neutron, 2 electrons, and lithium, 3 proton, 3 neutron, 3 electrons. And similarly, this is lawrencium, so 103 protons, 103 electrons, and but large number of neutrons, 159. So similarly, uranium, 92, so 92, 238. So it has a large number of neutrons. So neutrons 146 in 238, and 143 in 235 uranium rare isotope. So this is the structure of an atom in different elements. So we consider a simple atom, which is a hydrogen atom. So it is consists of a one proton and one electron. So this it has only Coulomb force, which is inverse square law of force. So force is proportional to the distance in between two particles. So we are considering classical mechanics. So F is equal to 1 over 4 pi epsilon. Q1 charge of the nucleus, Q2 charge of electron in over R square, the distance between them. So because of the inverse square law, so it is represented like this one. So the force is when our distance is very large, infinity, force is zero, and in positive x axis and negative x axis, or if it is one dimensional. So F is equal to nearly zero. Uh, uh, F is nearly zero or infinity when R is equal to zero. So there are two extremes, but in between we can consider this one. What is the energy of bringing electron from far distance to another distance? So this is the force, and this is R1 and R2. So energy is work. Work is a force F dot D. D is a displacement. So it is R1 to R2. So bringing particle from R1 to R2, how much is energy is required. So F dot dr in this direction is moving, and F is increasing this distance. If you consider instead of two parameter, one parameter, so F R is infinity. So we're bringing particle from infinity toward this uh, uh, nucleus. So it is this is minus sign r1 to infinity f dot dr. So because the two directions, force and distance direction are opposite, so this is this one. So this is numerically equal to 1 over 4 pi epsilon q1 q2 over 1 over r modulus. So it depends upon uh, only distance, inverse of the distance. So energy look like this one. So it is Fr is infinity, energy is equal to 0. So it goes like asymptotic behavior in both positive and negative displacement direction. So E is infinity when R is equal to 0. So it Coulomb law doesn't hold. So then there is another force which is active, which is a strong and weak nuclear forces. But the energies are quantized so that there is different levels. So the lowest level of hydrogen is minus 13.6 electron volt, and next step, second level, it is situated at minus 3.4 electron volt. This is first one. So the lowest state is minus 13.6, and if electron is given enough energy, so it can shift itself from lowest to first excited state. So the energy difference is if it is supplied between these two levels. So an energy of an nth state is given by minus 13.6 over n square electron volt, where n is equal to, if it is equal to n1, so this is the lowest state, and this is the next excited state level. So this is isolated one electron, one atom. So this is hydrogen atom, and this is helium atom. This is the lowest energy level of hydrogen, which is minus 13.6, but helium has a further lowest level of energy level, is ground state is minus 54. But the second state, first state, so this is the first state, and first excited state or second level is minus 13.6, which is exactly the same as the hydrogen. So the hydrogen ground state, and this is the second stage of helium. Hydrogen second state, first excited state is uh, fourth state. This is one, first, two, three, fourth state, excited state. So this is fourth, and this is second. So different atom of different element have a different energies of levels. So consider the case of hydrogen. So bringing two hydrogen atoms close to each other. So the atom first, atom 1, atom 2 bring together. So this is a minus 13.6. This is also have a minus 36 point electron volt, the lowest energy, and that mean that if you want to excite or ionize this one, so first atom, you have to supply a minus 13.6 volt energy, so then it will come to upper will be at the outside the influence of the Coulomb force of the atom. So it will be on the periphery of atomic uh, radius, so zero energy, so it will be ionized. So but if you bring two atoms close to each other, and So there will be a different thing will happen. So if you bring together this hill, the top will reduce, and then now it's a less amount of energy is required to jump this electron to on this atom side. So because it is this is a gap, so because we have to bring two atoms closer, bring it to atom closer, that means and temperature is very high, and there are too many collision each other. So if you bring more and more closer, so this height will be reduced and less energy is required to move electron from one atom to another one. So if it is very low, so that bringing very close to each other, then they will have nearly the same kind of lowest energy level. So there's no need for energy to supplied, so they can move freely. So this, if it is two electron, if there are many electrons, they will have this kind of arrangement, so that their energy level will be kind of electron will be able to move from one a nucleus to another one. So this one, so here there are two concepts. So energy capacity, say atom 1 has a 2 electron capacity, atom 2 has a 2 electron capacity. When they combine together, two atom, they will have a 4 electron shared, but this is the same energy, this has the same lowest energy, as you have seen, same energy level. So like this one uh, minus 13.6, this is minus 13.6, same energy. So, but when you combine these together, they will have different energy. And this is not a hydrogen when discussing journal. This is a one concept, number one. Number two is a Pauli exclusion principle that says that no two electron can have a same quantum number. So similarly, that if is a one wave function of one atom is symmetric. So this one plus this one is a superposition of the two, uh, bringing together. So their probability of finding the electron, so it is a phi square. Is the that is the amplitude square. So this wave function plus this wave function, this will enhance this one. So probability of finding the electron is maximum at the central point. But if you have asymmetric wave function, so this is a positive and this is negative, they will combine together. So they will cancel each other in the center region, so that there will be minimum probability of electron finding in the center region. So maximum probability, uh, maximum, and here is a minimum probability. So that means uh, two different probability, two different energy levels. So before bringing the two atom together, atom 1 and atom 2, so orbital same energy, this has a minus 13.6 minus 13.6 electron volt, this has also minus 13.6 electron volt. So in case of hydrogen, so one electron, bringing them together, so they will have two uh, uh, electron with the uh, two electrons, but have a different energy level. So one plus one electron plus one electron, they will split together, split into have a two different energy levels. So lowest energy level is a bonding, and a higher energy level is anti-bonding. So anti-bonding, so this is so if you, instead of two electrons, two atoms, if there are many atoms, atom 3, 4, 5, so on, if many electrons. So that mean their energy levels. So they will be split. So if it is split, then will be a full energy band, and there will be a partial band. In partial band, there will be some occupied and there will be some unoccupied. A very small amount of energy is required to jump uh, in this one. So to jump to this level, so they can move and can move and contribute to the conductivity of electric current. But in the case of a full band, if the band is full, now they cannot move to this surface. They have to move to the from the this one to upper level. And if the band is full, then the electron need a large amount of energy to jump up to the next energy level, energy band, because of the large band gap. If the band gap is more than 5 electron volt, then material is called an insulator. Otherwise, if the band gap is there's no band gap, uh, so if there is a no band gap, so then like this one, so then they will have a conductor, and the semiconductor, the band gap is in between one electron or volt. So this is the concept. It is important concept is here that two electron, when they are separated, they have a different energy level. When they have combined, they come closer. They have sharing, and they will share two atoms. So electrons have a connection. So this one and this one. So this atom, this nucleus, and electron are shared. So this is covalent bonding. Covalent bonding. So it is stronger because for this covalent bonding, so energy is one is have a lower energy and higher energy. So this has two levels split into two level of same energy split into two level of different energies. So if there are many atoms, so they contribute, and then they have instead of levels, they have a band. So this band gap, energy band gap, is the particularly important for the property of conductivity of solids. So that's it, and we will explain later about the semiconductor, how semiconductor works.